Its core starts changing, it starts bloating and getting so large that it will engulf the orbit of Mercury and Venus and come very close to Earth. So imagine looking on the horizon and sunrise is half the sky. Prepare for a cosmic revelation as a quarter of scientists unveils an astonishing interstellar revelation. Betelgeuse, the captivating red supergiant gracing Orion's shoulder, has undergone a celestial explosion. This is not a jest. In the coming decade, or perhaps within a few decades, the radiant aftermath will cast its luminance upon the night sky. The question arises, how did scientists arrive at this assertion? Should we harbor concerns, and can the James Webb Space Telescope capture Betelgeuse's remnants? Today, we embark on an exploration of the most recent developments. Betelgeuse, a preeminent star in the winter night sky of the northern hemisphere, is a red supergiant. It distinguishes itself as one of the few stars whose reddish-orange hue is discernible to the naked eye. Normally the 10th brightest star, Betelgeuse's luminosity varies, a peculiarity attributed to its colossal size. To put this into perspective, replacing our Sun with Betelgeuse would extend its reach to the asteroid belt, boasting a mass an astonishing 20 times that of our Sun. Surprisingly youthful, Betelgeuse's age is estimated at 8 to 10 million years in stark contrast to our Sun's approximately 4.6 billion years. The accelerated evolution of supergiant stars leads to rapid nuclear fuel consumption and supernova occurrences on geological timescales. Betelgeuse may have undergone this transformation before our very eyes. To comprehend the scientific claim of Betelgeuse's explosion, a journey through its context is imperative. The narrative commences in the 2nd century BC when Chinese astronomers noted Betelgeuse's distinct yellow hue. Progressing to the middle of the 2nd century AD, Greek-Roman astronomer Ptolemy described it as orangish or ruddy, akin to its present appearance. Medieval observers in the Middle East also reported a similar coloration. While questions linger about past color perceptions, a plausible scenario emerges: Betelgeuse transitioned from a yellow supergiant to a red supergiant over several centuries. Given humanity's natural inclination to observe the night sky, the potential for numerous unrecorded witnesses to these changes is ponderous. The present unfolds with Betelgeuse as a variable star exhibiting cyclical behavior. Notably, in December 2019, its brightness experienced a drastic dip, observable to seasoned stargazers, returning to its normal state by early 2020. A theory suggested coinciding cycles causing an unprecedented dip. However, Hubble Space Telescope observations unveiled a peculiar development: Betelgeuse had expelled an immense quantity of scorching material into space, forming an expansive dust cloud. The enigma of Betelgeuse beckons, and we delve into the unfolding saga to decipher its mysteries. In response to the expulsion of material during the 2019 event, a substantial dust cloud enveloped Betelgeuse, diminishing a considerable portion of its light when observed from our vantage point. The transformation was truly remarkable, causing Betelgeuse, once positioned among the top 10 brightest stars in the night sky, to fade significantly, plummeting beyond the 20th brightest. This dimming, contrasting sharply with its neighboring star Aldebaran, which holds the 14th position in brightness, left observers perplexed. Fortunately, Betelgeuse exhibited signs of recovery, but its enormous behavior persisted. Presently, Betelgeuse is engaged in a peculiar state, surpassing near-dimming. Over recent months, it has undergone a remarkable surge in brightness, exceeding its usual luminosity by an astonishing 50%. This bewildering development is disconcerting for a star renowned for its fluctuations. While dimming events may be attributed to dust, coinciding cycles, or significant sunspots, a notable increase in brightness introduces an entirely different element. It is speculated that the material expelled in the 2019 event disrupted the star's plasma flow, potentially causing the current behavior as an aftershock. A conservative hypothesis, extensively debated, posits that Betelgeuse may be approaching the supernova phase. Despite conservative estimates suggesting a supernova event is approximately 100,000 years away, a recent scientific paper by Hyuki Seo and colleagues from Tohoku University in Japan challenges this notion. The paper proposes that Betelgeuse has already undergone a supernova explosion, and we may witness the aftermath within the next 10 years or a few decades. The evidence supporting this claim stems from a thorough examination of Betelgeuse's variability patterns. Researchers identified 4 distinct periodic changes occurring at intervals of approximately 24, 12, 230, and 185 days. While the origin of the longest period remains unknown, it is speculated to be the fundamental period, with the shorter intervals potentially serving as overtones. The model proposed suggests that Betelgeuse is in a late stage of carbon burning, hinting at an imminent and spectacular explosion, positioning it as a leading candidate for the next expected supernova event in our Milky Way galaxy. However, unraveling the Betelgeuse mystery is akin to solving a puzzle with conflicting observations surrounding material ejections and subsequent recovery. The general consensus leans toward a mass ejection event, a phenomenon not entirely unprecedented for various types of stars, albeit on a smaller scale than our Sun. Supergiants, though, are a different reality, with the last observed one in our galaxy dating back to Kepler's supernova in the 1600s. Despite the possibility of inaccuracies in Betelgeuse's explosion timing estimates, caution is advised before making concrete plans around this celestial event. Adding to the complexity, Betelgeuse is currently elusive to observation as it has moved behind the Sun and won't be visible again until at least August. While the enigmatic star's current activities remain obscured, the unusual brightening trend stands out. Notably, Betelgeuse's substantial size and relative proximity, approximately 650 light-years away, allow us to discern a disk when observing it, a unique advantage compared to most stars that appear as mere points of light due to their greater distance. With Betelgeuse, we are presented with a unique opportunity to directly capture variations in its light output through photography. This star, potentially on the brink of going supernova, offers a wealth of data, including somewhat blurry images. Envisioning the scenario where Betelgeuse undergoes a supernova, it promises to be a genuine spectacle. Reassuringly, this cosmic event poses no threat to Earth, given Betelgeuse's considerable distance. While the supernova won't outshine the Moon or the Sun, it would cast shadows at night and remain visible during the day for about a year. The supernova's brilliance would persist at night for several years, gradually fading away. Although there might be a brief period of increased brightness, the familiar shoulder star in the constellation Orion would ultimately disappear. While the supernova won't harm us, it could potentially confuse certain creatures reliant on moonlight for navigation. This celestial event would present challenges for astronomy, especially during nights illuminated by the moon. Despite potential complications, telescopes would likely prioritize capturing the supernova's glory, even if adjustments are needed. Warning signs, such as the detection of neutrinos and gravitational waves, would precede the visible explosion, affording astronomers the opportunity to prepare their instruments. Addressing the question of whether the James Webb Space Telescope, JWST, has observed Betelgeuse's remnants, unfortunately, the Webb Space Telescope hasn't had the chance. The star's excessive brightness makes it unsuitable for the JWST, designed to spot faint objects in space. Betelgeuse's infrared K-band magnitude, significantly brighter than the JWST's saturation limits, renders it incompatible for direct observation. Despite the JWST's limitations, other observatories, both on the ground and in space, eagerly await the opportunity to capture this cosmic spectacle. The aftermath of Betelgeuse's supernova would be a subject of intense scientific scrutiny, akin to studying the Crab Nebula, a remnant from an 11th-century supernova. The post-supernova scenario for Betelgeuse hinges on the amount of material left behind, potentially resulting in the formation of a neutron star or even a black hole. While Betelgeuse's instability is apparent, its surface does not reveal the deeper workings of its core. It remains uncertain whether the star is on the verge of a supernova or if it will return to normal cycles. Alternative models suggest the explosion might not occur for tens of thousands of years. Ultimately, only time will unveil the true fate of Betelgeuse, emphasizing the ever-changing nature of the night sky and the impermanence of stars in the vast expanse of the universe. Let us continue to marvel at the cosmic wonders and embrace the mysteries that unfold over both short and long timescales.